When the polynomial p of x, which equals x cubed plus ax squared plus x plus b, is divided by x plus 1 or x minus 2, the remainder is 0. We need to find the values of a and b such that this is true. So if we divide a polynomial by x plus 1, that's the same as evaluating it at the value -1, and that's by the factor remainder theorem. So when we evaluate at -1, we have -1 cubed plus a times -1 squared plus -1 plus b. And because the remainder is 0, p evaluated at -1 will be equal to 0. So if we continue working this out, we have that -1 cubed is -1, plus -1 squared is just 1, so we just have 1 times a, minus 1 plus b, which still equals 0. And if we add 2 to both sides and subtract a, we can find that b is equal to 2 minus a. And that becomes our first equation in solving this problem. The next thing we do is we evaluate p of 2, because x minus 2 gives a remainder of 0, means that when we substitute 2 into the equation, so let x minus 2 equal 0, x equals 2, when we sub that into the equation, that should equal 0 as well. So we'll have 2 cubed plus a times 2 squared plus 2 plus b, which equals 0. And now 2 cubed is 8, plus 2 squared times a is 4a, plus 2 plus b equals 0. And now if we do some rearranging to that, we can find that 4a plus b is equal to -10. And that will become equation 2 when we're solving this problem. So the next thing we're going to do is we're going to substitute equation 1 into equation 2. Equation 2 is 4 times a plus b, but we're going to replace b with 2 minus a, and that's going to equal -10. So all up, 4a minus a is going to be 3a plus 2 equals -10. Subtracting 2 from both sides gives 3a is equal to -12. And dividing by 3 gives a is equal to -4. So with that piece of information, we're now going to substitute a is equal to -4 into one of the equations. So because equation 1 is simpler than equation 2, we're going to sub it in there. And we're going to find that b is equal to 2 subtract a, but of course a was -4, so we have 2 subtract -4, which is +4. Therefore, we find that b is equal to 6.